Welcome friends to the course of marketing research and analysis. So, today we will be starting with a new topic which I had also discussed earlier in my in the first course which I had done on marketing research and analysis. There I had explained it theoretically, the basic conceptualization, the basic meaning of factor analysis, which is the data summarization, data reduction technique, right. But today in this course the objective is that because we found lot of queries from people coming on that they need to understand it through how to use it. So, that application part was lacking in the first session, first course. So, that is what we have tried to incorporate in this one, right. So, today we will be starting with this factor analysis in SPSS. So, what is factor analysis basically? Factor analysis is a data reduction technique, sometimes it is called a data reduction or data summarization, right. So, data summarization technique. So, this is basically, as it says, is a class of procedure used for data reduction summarization. So, it has a lot of utility. So, we will see what is the utility, right. It examines the interrelationships among a large number of variables. So, suppose you have got a large number of variables, let us say during a study you on some psychological study you want to understand the personality or the traits of people, right. So, when you are trying to understand the traits or personality of people, there could be maybe 50, 60 such traits which are there and they are and you are observing them. But if you start understanding or trying to explain all these 60 maybe 60 traits, then it becomes very cumbersome, very complex, right. So, in such a condition there is a necessity of reducing this number of variables to a few known factors which can explain it more easily. Okay. So, it is just to make a structure little more simpler, that is the meaning, right. So, as it says, it examines the relationships among a large number of variables and then attempts to explain them in terms of their common underlying dimension. So, what is this common underlying dimension? The common underlying dimension is, you have to understand that the whole philosophy of factor analysis is basically it is dependent on the correlation among variables. That means, how two variables are correlated, what is the degree of correlation among them, that is what actually is the core of factor analysis. Okay. Although it looks, it is like a regression, it is very similar to a regression only, right. So, the heart of the basic algorithm is on the correlation, right. The common underlying dimensions are referred to as factors. So, as I said, suppose you have 60 traits, right, of psychology, and these 60 traits are very difficult to understand, because if you want to go on explaining each one of them, it is very tough, complex. So, let us say I do a factor analysis and the objective is to create some few factors out of this, and let us say I generate, let us say 5 factors. Okay. So, that means what has happened, the 60 traits have been condensed, has been compressed to 5 factors, okay, and these 5 factors are representative of these 60 traits. Okay. It is an interdependence technique. Why it is an interdependence technique? Because the concept of dependence and dependent variable and independent variable does not exist here, right. So, we are not talking about any cause and effect relationship, there is no there is no outcome and there is no predictor, right. So, that is why it is called an interdependence technique, all the variables are correlated to each other. Example, a car manufacturer's image may be measured by asking respondents to evaluate cars on a series of items on a semantic differential scale. I hope you understand about a semantic differential scale. A semantic differential scale is a scale in which you have bipolar adjectives, right. So, for example, lazy and you have somebody opposite of lazy is agile, you can say agile, right. So, there are 7 space 7 numbers in between. So, this when you the semantic differential is a scale which is similar to a Likert scale, but the only difference is that the Likert scale is an itemized scale where every item is being explained, has to be explained, right. For example, when you say 1 2 3 4 5 6 7, what 1 means, what does 2 stand for, what does 3 stand for, what does 4. So, the only difference between semantic differential and Likert is this, that in the Likert scale you are explaining what every number means, right, how do you describe it, and in semantic differential we give two bipolar opposites, right, let us say ugly beautiful, lazy agile, right, or active beautiful, and there are 7 points, right, and where does the person, the respondent want to fix its observation or its opinion, he can fix it here, right. So, these item evaluations may then be analyzed to determine the factors underlying a car manufacturer's image. So, I just told you the better example is, maybe we can take this 60 traits of psychology. Okay. Factor analysis is used in which circumstances? Let us see. First is to identifying the underlying dimensions or factors that explain the correlation among a set of variables. So, as I said, the heart and spirit is the correlation, right. So, then once that means what, 60 traits came down to let us say 5 factors. Okay. To identify a new smaller set of uncorrelated variables to replace the original set of correlated. Now, you see 60 variables were there, all related to psychology. Now, we have got 5 factors. Now, each factor is separate from each other. When I will talk about validity, we will use a term called discriminant validity, right, convergent validity, discriminant validity. What is discriminant validity? It says that one factor is sufficiently different from another factor. Okay. So, when you have let us say to identify a new smaller set of uncorrelated variables, so these are the uncorrelated variables, to replace the original set of correlated ones, right. So, we are replacing this 60 with this 5, right. Suppose 7 variables generate 2 factors, these factors are used as independent variables in regression. So, the whole objective is, suppose you want to use these factors, let us say now, or you wanted to use these variables as a independent variable in the regression equation. So, y is equal to, so you could have had now in this case up to x 60, right. Instead of having this x 60, what we are doing is we are using these 5 factors, right, the scores of these 5 factors. So, x1, x2, x3, x4, x5. So, this may be taken in as the the variables, right. Or another example I have given is there are 7 variables where 2 factors have been generated, and these 2 factors are nothing but they represent the 7 variables. Okay. To identify a smaller set of salient variables or important variables from a large set for use in subsequent multivariate analysis. So, you can drop variables. So, it helps also to identify the variables which are highly similar, right, and which can create a problem of multicollinearity and drop them, right. So, you have understood by now when we did regression that multicollinearity is a very serious issue, right, and what happens when there is a problem when multicollinearity exists. If multicollinearity exists, the entire coefficients can become disarrayed and the signs can become opposite of what they should be, and similarly the whole the study can become insignificant. So, it can pose serious trouble, right. So, it helps you to drop variables and understand after understanding where there are too much of correlation or extremely strong correlations. Okay. Some areas of application of factor analysis is market segmentation. So, in market segmentation we use it to identify the underlying variables on which to group the customers. How do you want to group the customers? Let us say that on the psychological traits you can understand, and maybe 2-3 psychological groups you can form and say, well, this group needs this kind of a service or product and this group needs this kind of a product. So, that is how you segment the market, although classically we use the cluster analysis for market segmentation, but factor analysis also can help you. Product research, factor analysis can be employed to determine the brand attributes that influence consumer choice, fine. Similarly, advertising studies, it is used to understand the media consumption habits of the target market, right, and in pricing studies it is used to identify the characteristics of price sensitive consumers. So, there are several uses of factor analysis in the marketing sphere, right. Now, what are the assumptions? There are some assumptions. For example, you should have multiple variables which are measured at a continuous scale. So, you can measure it in let us say continuous scale. So, for example, in a Likert or in any interval or ratio scale, and there needs to be more than a sufficient number of variables should be there. So, that then only the point of factor analysis is justified. Otherwise, why should you do a factor analysis when only 3 or 4 variables are existing? there needs to be a linear relationship between all the variables. That means there needs to be a linear relationship among the variables, which I have explained what does linearity mean, right. So, every variable should be connected linearly in a linear fashion, so that one change in the change in one reflects a similar corresponding change in the other, right. Sampling adequacy, which simply means that for factor analysis to produce a reliable result, large sample sizes are required. Now, I will tell you what are the sample sizes. Initially I have also said, I think. So, for any study there is a thumb rule that the number of variables into ideally the best is 20. So, if you have let us say 15 variables, then you need 20 respondents for each or samples. So, that comes to 300 sample size, right. But and this can go up to, if you do not find it is a difficulty, then the up to 10 is desirable, right, but below 10 it is not desirable, right. So, data should be suitable for data reduction. Now, your data should effectively you need to have adequate correlations between the variables. Now, this is very important, as you will see there is a Bartlett's test of sphericity which is done to show that at least some correlation between the variables exist. If there is no correlation, then factor analysis is of no use, you should not be doing factor analysis at all. Okay. Outliers should not be present as much as possible. The sample must be homogeneous, and interdependence of observations, again the same sample must not be repeated, right. So, how does mathematically factor analysis look like? Like multiple regression, factor analysis also is expressed similarly. Here in that you see mathematically factor analysis is somewhat similar to multiple regression analysis, in that each variable is expressed as a linear combination of the underlying factors. Now, let us see. So, x, right, is equal to, x is the standardized variable, right, xi is the standardized variable, a is my standardized multiple regression coefficient, okay. F1 is my common factor. So, F1, F2 are my factors, right. A is my standardized multiple regression coefficient. So, as you have by now you have understood the coefficient, like you have the slope, the coefficient, beta coefficients, right. So, Vi is the standardized regression coefficient of variable I on common factor j, right, and Ui is the unique factor. Now, there are two terms, the unique factor and the common factor. So, for example, if you when you know like a shared variance, so something you know this is shared or common, right, and some are unique. So, it talks about the these are the unique factor for variable I and the standardized regression coefficient. Anyway, just understand this, if you want, if this is more, it looks more like a regression equation, multiple regression equation, right. The unique factors are uncorrelated with each other, the unique factors are uncorrelated with each other and with the common factors. The common factors themselves can be expressed as linear combinations of the observed variables. Let us see the first factor. The first factor, you should remember in factor analysis, when you get several factors, the first factor explains the highest amount of variance, the second factor explains the second highest amount of variance, the third factor explains the third highest amount of variance, right. So, as you go on, you see the first factor, let us say the Fi is the F1. So, estimate of the ith factor is equal to weight of the factor score coefficient, weight or factor score coefficient. Now, factor score I will explain in the next slide, maybe it is there, into the x is the variable, right. So, this will tell us this will give us the individual factors variance, or how much of variance in the study is this particular factor explaining, right. So, there are some statistics associated with factor analysis. First is commonality. What is this commonality? Is the amount of variance a variable shares with all other variables being considered. Now, how does it look like? For example, let me show you. Let me show you both eigenvalue and commonality at the same time. Eigenvalue represents the total variance explained by each factor. Now, let us say these are the factors F1, F2, F3, F3, right. So, the loadings, let us say this is L11, L12, L13, right. So, these are my variables this side, and what I do is I just take the square of these, right, the sum of the square of these, and this summated value is what is called my commonality, right. So, this is my commonality, and when I take the across the variables, as I take the summation of this on the vertical. So, the summation here of let us say for factor 1, let us say this is called my eigenvalue, right, eigenvalue, right. So, as you can see, commonality is the amount of variance a variable shares, right, with all the other variables. Now, this variable let us say V1, how much it is sharing with all the other variables through the factors, let us say factor 1, factor 2, factor 3, let us say how much it is sharing. This is also the proportion of variance explained by the common factors, right, and the commonality should be more than 0.5, should always be greater than 0.5, right. Similarly, if you look at the eigenvalue represents the total variance explained by each factor. So, for F1 explains how much. Now, this is the square. So, this let us say 2 1 square square 3 1 square L4 1 square. So, the summation of this is called my eigenvalue, right. So, this is very simple to understand, and this tells me what now it explains the total variance of each explained by each factor. The eigenvalue represents the total variance explained by each factor. Okay. So, similarly for F2 and F3 we can find out. What are factor loadings? These are simple correlations. So, these are the factor loadings, right. The simple correlations between the variables and the factors. So, the factor and the variable, these are the loadings. So, these loadings are nothing but simple correlations, right. Factor matrix. A factor matrix contains the factor loadings of all the variables on all the factors extracted. So, if I draw the entire chart here, so this will be my factor matrix. Okay. Factor score. Now, what is this factor score and what is its use? We will see later on, but just now to understand. Factor scores are composite scores, right, estimated for each respondent on the derived factors. It is computed based on the factor loadings of all the variables. So, factor score for example, here you see factor 1 score. So, is B11 x1 plus B12 x2 B13 x3, it goes on. So, there is another term which is similar, which is called the summated scale. If you can see here, factor scores sometimes during a factor analysis or after doing a factor analysis, we use the output of the factor analysis or the factors for for conducting some other studies, for example, a regression study, right. So, there what are the variables we will take? So, we can take the factors scores as the variables, right. So, you can take the factor scores, or you may take another term called a summated scale. So, what is the summated scale and what is the difference between factor score and summated scale, I will explain. So, summated scale is the average score of the combination of all the variables loading highly on a factor. So, that means what? When I am doing a factor score or I am doing a summated scale, there are two differences. There is one difference, sorry. The factor score, I may use it as an input for a multiple regression analysis, or I may use the the variable after doing a summated scale analysis. Now, what is the difference? But the factor score, you remember, is derived by using all the variables used in the study, right. But summated scale only uses the respective variables which are loaded onto the factor. Are you getting my point? Suppose there are 10 variables. So, if you want to calculate a factor score, so all the 10 variables loadings are to be taken. But suppose I am doing a factor summated scale and factor 1 has got loaded with only 1, 3 and 4, the variable number 1, 3 and 4, then only the each respondent score will be summed up. That means, what he has given the score for question number 1 or the variable 1, variable 3 and variable 4, this will be taken summated and the average will be recorded. So, this new column which we generate, right, is called my summated scale, right. So, this summated scale has a very large implication and it is sometimes considered better and easy then instead of taking the factor score, because factor scores have their own complications also. They have their own difficulties because they change every time with the change in the respondent. So, calculation becomes extremely complex. Okay. Percentage of variance, the percentage of the total variance attributed to each factor. Now, during a study when we will conduct a factor analysis, you will see that every factor contributes something to the variance, right. Variance means how much is the explained, how much of explanation is being done by this factor, let us say. So, there are let us say 5 factors. So, 5 factors let us say are explaining us 70% of the study. So, then we have to have a understanding ki is it sufficient or not. Sometimes when you are doing a factor analysis, there will be some loss of variance, that means explanation power will be lost, there is no doubt about it. But how much are we losing? Are we losing too much of explanation power? If we are losing too much of explanation power, then our study is not doing well, right. So, whenever you draw factors, you should ensure that your factors are sufficiently explaining a large amount of the variance, right. Then we can say, well, although we have lost some explanation power, but it is not too much, right. So, what is that value of variance that you can expect? Now, at least you should be, the study should be explaining about 60% minimum. In a social science case, we will say the factors should be at least contributing 60% of the variance of the study, right, that is minimum, right. Scree plot, it is a plot of the eigenvalues against the number of factors. So, it helps to identify the number of factors. This is a scree plot, you can see. Now, how do you identify the number of factors to be considered? Now, you can take the points where it is changing. So, 1, 2, right. So, after this if you see there is a steadiness, right. So, however, there is no more change here. So, we can say, well, up to this much. So, there are 3 factors to be generated, right. So, scree plot is a diagrammatic representation, that is all. Now, how do you conduct the factor analysis? So, you have understood the importance of it, the steps also to some extent. Let us go the importance of it and where it is used. Now, let us understand the steps. The first step, first step is, there are 4 steps. The first step says the correlation matrix for all the variables need to be computed, right. First, draw a correlation matrix to see that there is some correlation among the variables that exists. If correlation among the variables is not existing, is very weak, then factor analysis is not the right tool. Okay. Then how to extract the factor? Third, that means you are extracting the factor at this stage. Third, you are rotating the factor. Sometimes we will see that while doing it, that after you extract the factors are not properly explaining all the variables, right. Most of the variables are loaded onto one factor only, right. So, there is a problem. So, we will have a problem there. So, how do we come out of that problem? Then there is a technique called rotation, which I will explain. So, when you rotate the variables, let us say if this is my axis, let us say if I rotate the axis, then what will happen? The variables will be sized in a much better form. So, this will help in better explanation of the variables. Okay. So, and finally, is to make final decisions about the number of the underlying factors, how many factors you want and what are the you have to give a name to them, right. So, these are some of the steps in the factor analysis. So, what we can do is we will continue in this the same lecture in the next class, but try to understand that factor analysis is a very important technique which needs to be very clearly understood. There is a lot of misutilization also here. People try to do anything and everything with and run a factor analysis. You should be very clear that factor analysis also needs a theoretical needs a very sound theoretical background, right. So, when you are doing a factor analysis, when you are creating the factors, it is not possible that there is no theoretical explanation behind it. It has to have a theoretical explanation, right, because if the variables are correlated, we should know why they are correlated and whether they should be correlated or not. That has to be there, right. So, sometimes people can why I am saying this is because people can give you, respondents can give you scores without checking or not in a very serious way. So, there wrong correlations can generate and wrong factors can generate. Because the wrong factors means, in the sense the factors may encompass wrong variables, right. So, for that reason you need to be very careful that a theoretical understanding also has to be there, right. Anyway, we will continue this in the next class, right, lecture, where I will explain the details about the factor analysis. Thank you so much.